Over the last 17 years when we went to the Greenland Ice Sheet, we started off making climate measurements. Since 1999, we realized that the climate, the weather, gets much warmer on the ice sheet. The ice that melts increases, and we realized there were more icebergs going out into the fjord. Having this big melt, that generates a lot of melt ponds. That means small lakes on the ice sheet. And this water flows down into big holes. We call them moulins. And that's where the water goes into the ice and all the way to the underside of the ice sheet and lubricates it. And that's why the ice is moving much faster towards the coast. The problem is a moulin like this. None of my grad students volunteered to go straight down this hole to make the measurements. So we were developing instruments that we can insert into these moulins. And I have one example here. This is a laser that shines a pulse and measures the reflection. So you can measure the volume of these cavities. In the lower part, I have a camera system. And last season and the season before, we put that down about 300 feet vertically down and got the first information about how does the water flow into the ice sheet, what is the ice properties. It was all designed here in CIRES, actually. We developed this kind of instrumentation, which is unique, because as a research unit, we are not just working in atmospheric science. We have engineers working with us. We have a workshop within CIRES that builds these instruments. We designed it. I have collaborators in aerospace engineering. They helped me out with the radars, with the laser system. And we have radar as well. These are wavelengths that can look through the ice. So we can map the entire ice sheet all the way to the bottom. And then with the computer graphics, you can dive in. Instead of my grad students diving in, we go in with our computer.